Welcome and hello. This is a support video for HEC ResSim, and in this video I'm going to be discussing reach calibration. I got a question in from one of the viewers asking about reach calibration, so I'm going to make a quick little video about it. The question is on the screen here, and it's this. When I set up the reach routing in HEC ResSim, I noticed that there's an observed option. What is the function of that option? Does it mean that I can compare measured data input or something? And the answer is yes. The observed featured in ResSim allows the user to compare model results with observed real-world data as a way to calibrate the model, specifically in this case, the reach routing. So that's what we're going to do in this video. So I got ResSim up on the screen here. Let's go ahead and start from the very beginning. Actually, I don't want to open. If I want to create a new watershed, I need to make sure the module is set to watershed setup. Okay, File, New Watershed, and then select the directory that you want this to be saved in. Okay, so that's there for me. I'll just call this project English units, and then we'll go with pick a time zone. All right, apply and okay. And okay. All right, we're ready to get started here. First, I'm going to go up to View, Layers. I'm going to change the projection. So I'm going to go Map, Map Display, and then Edit. I'm going to use UTM. And okay, now I want to set the extents to something much larger than just 1,000 feet in each direction. I'm going to say the easting ranges from 0 to 30,000, and then the northing ranges from 0 up to, we'll say 20,000. So 2 to 3 aspect is usually the screen size that I use here. Okay, and okay. So now the northing and easting coordinates are showing down here in the bottom left. So I should have my 0, 0 down here, and then my 20,000, 30,000 up in the top right corner. Next, I'm going to sketch out my stream alignment. So I'll click on the stream alignment tool, hold down the control key, single left click, and then continue holding down the control key and doing single left clicks just to give the stream or the river a little bit of a curvature. Let go of the control key and then a last single left click. I'll call this river A. And then let's see here. I'm going to add a couple computation points. So click on computation point, hold down the control key again, single left click on the stream alignment. I'll call this CP1. This will be the upstream computation point or junction point, and then CP2 down here at the downstream end, CP2, and that is good. Last thing I want to do here in the watershed setup is create a configuration. So I'll just go configuration, new, config 1. I'm using ResSim 3.5.1, so I don't have to put in a time step or click the lock button or anything. The base date is well, sort of optional as well. Apply and okay. All right, so we have the config 1. This is all we need to do for the watershed setup. So I'll save that, click on reservoir network, and then create a new network. I'll just call it network 1. It's going to be our only network, and make sure to select config 1 for the configuration so that the junctions will pop into place. Boom, CP1 and CP2. All right, I'm going to sketch a reach now between those two junction points. I'm going to click on the reach tool right here and then hold down control, single left click on the upstream junction, let go of control, single left click on CP2, which is my downstream junction. The name of the reach is right here. It says CP1 to CP2. That's fine. It's going to be my only reach. And next we want to assign an inflow to our upstream junction. So I'm going to click on the junction tool, right click, edit junction properties. And then for local inflow tab, I'm just going to call this CP1 and then a factor of 1. Sorry about that. Oh, okay. The name's been reused. Let's just call it CP1 inflow. CP1 inflow and factor of 1. Apply and okay. All right. One more thing we need to do here is add observed data down here at CP2. So I'm going to go right click, junction properties. Now we don't want local inflow, but we do have this observed data right here. So I'm just going to say flow and then click apply in the bottom right and then click OK. So once we create an alternative, we'll be able to assign the observed flow. So inflow at CP1, we'll have a time series data set for, and then the observed flow down in CP2 we'll have a time series data set for. And then it's up to us to figure out what sort of reach routing and potential losses that we're going to use in the reach between CP1 and CP2. And we have a bunch of different routing methods here. Null routing is the default, but there's coefficient routing, Muskingum routing, Musqueam, Kung 8 point, and so on. So there's lots of different options and ways to model the routing of a reach in ResSim. Okay, let's hop over to DSS view and actually create a DSS file and input some data for the inflow and the observed data. Navigate to where we want to save our data file. I'll just say data.dss. Okay. To input a new time series data set, we'll go up to Data, Manual Time Series. The first data set I'm going to add is the inflow at CP1. So here is the path right here. And I'm going to start this on January 1st, 2020 at 0 hours. Units will be in CFS and the type instantaneous value. Down here is where I paste in the actual data or type it in, but I have it saved in an Excel file right here. So I have 3 different paths. Here's going to be my inflow at CP1, and then here is observed flow at CP2, and then a different data set for observed flow at CP2. So I'm going to be entering in 3 time series data sets into DSS view. The first one's right here. So I'm just going to copy onto my clipboard and then paste. Okay, save. No. Okay, we're going to do that 2 more times for the 2 observed flows at CP2. So data, manual time series. We're going to call this observed 1. So I'm going to paste in the path. Parts pop into place there when I tab off. And then as before, I'm just going to use the same date range or starting date. And then I'm going to go back to Excel. Now I'm going to grab the data for CP2 observed, and then back to DSS view, paste, save. Okay, one more time, data, manual, time series. Okay, I'm going to paste in the path name I'm going to use. The only difference is observed to, so I'll show you the path name parts in just a moment. Okay, I got the start date and time and units. So let's go over to Excel, grab that data, and paste it in. All right, so save, no. Here are the 3 paths that we just created. We have the inflow data at CP1, and then we have observed at CP2 and observed 2 at CP2. So inflow, observed 2, and observed and observed 2 at the junctions CP1 and CP2. If I plot all 3 of them together on this plot, here we have the inflow in green. Observed 1 in red right here just has a 30-minute lag, so it's pretty straightforward. That'll be easy to calibrate. What's not going to be as easy to calibrate is observed 2, which is yellow, which definitely has more lag and attenuation than what we saw in observed 1. Okay, so let's go ahead and do these 2 different calibrations and see what we get using ResSim. All right, so I'm back in ResSim. Reservoir network is still selected for my module. I'm going to go up to Alternative, Edit, and then create a new alternative. I'm going to call this Alt1, which is going to correspond to the observed flow 1, the 30-minute time step lag. Yeah, I should probably also mention in DSS view, I'm using a 15-minute time step for part E. I didn't explicitly state that, but if we look at the table data, you'll be able to see it starts at the beginning of the day, and then each time step is 15 minutes apart. So when I'm creating my alternative, I'm going to also use a 15-minute time step. Just wanted to be consistent there. Okay, so Alt1 is the name. And as I just mentioned, for Run Control tab, the time step is going to be 15 minutes. We don't have an Operations tab or a look back since we don't have a reservoir. This is sort of a different use of the ResSim model, but certainly still valid. And we're just isolating the whole reach routing, reach calibration process here. For CP1, I'm going to navigate to that DSS file, open up DSS, data.dss, CP1, set the path name. Okay. And then over here for observed data, what I want to do for Alt1, which is what we're editing, is use the observed flow at CP2, the first time series, the first observed time series. So I'm going to open up that data.dss file, open, and then select this observed path. Set path name, and then close. All right, we're good there. File, save. We can come back later to set up the second alternative that uses the second observed flow. But for now, let's just go ahead and run a simulation. So I'm going to close that. And then let's save the network and then save the watershed. Okay, simulation tab is next. I'm going to go simulation new. I'm going to call this sim1, which is going to be associated with alternative 1. So I'll check alternative 1 right now. The start and end date time, I'm just going to use the same date range as the time series data. I'm going to start it at 15 minutes in, and then it'll start at the beginning of the day. The look back period will and then the date will be the ending date time will be the end of the flow data, which is 15 hours later. Okay, so click OK. That's ready to go, and let's click compute. All right, so I'm going to click close and then look at the results. Right click on CP2 and then plot. And here we have essentially the exact same thing we saw from the DSS data, because currently we don't have any routing. It's just null routing. Where green here is the inflow in CP1 and also the flow in CP2, because there's null routing. It's just an instantaneous flow. Whereas red right here, this is the observed flow. Now, we know it's 30 minutes difference because, well, I created the data, but we can also look at the data itself. So it starts off at 500 CFS, 510, 530, 560, 510, 530, 560. So here's the 510 values, here's the 530 values, here's the 560 values, and so on. It goes on like that to the very end of the 15-hour duration. So we just have a 30-minute delay. So if we wanted to calibrate this rather simple calibration, then what we would do is add a reach routing. We'd go to edit run and then reaches. We only have one reach. It's this CP1 to CP2. For the routing method, instead of null, we just want to introduce a lag. So we could just say variable lag in K. And then we know that the constant lag is half an hour. So for hours, I'll say 0.5. And then for K, attenuation factor, we do not want anything, but I found if I put a 0, it doesn't let me run or doesn't let me save this data. So I'm just going to say 0.0001. So very small, pretty much negligible. Click apply, OK, and then let's run the simulation. Now let's take a look at the results and compare the observed versus the actual flow data at CP2. And boom, the two values are right on top of each other. Here is the CP2 calculated with that 30-minute lag. And then in red here is the observed data. So that's how that works. That was our simple example. Let's do a little bit more complicated example by using that second observed data set. So to do that, I'm going to go back to my reservoir network module, and I'm going to create a second alternative, Alt2, using that second observed data set. All right, so Alt2, okay. Most everything here is going to be the same. I'm going to just go with 15-minute timestamp. No operations, look back. This is going to be the same time series CP1 inflow data. So I'll just select that record, open up the data.dss file, CP1, set path name, close. Okay, and then in the observed data tab, now what I'm going to do is, again, select the data.dss file, but I'm going to select this second record for observed 2, click set path name, and then we'll be good to go there. So I'm going to save the alternative, close, and then we'll save the network and then change it to simulation module. All right, I'm going to create a new simulation. This is going to be Sim2. I'm going to use the exact same start and date time. So it will start at the second time period, so 15 minutes in. For the look back date time, I'll say the very beginning and then 15 hours for the end date time. This is going to use Alt2. Okay, so that's ready to go. Now let's just go ahead and compute it. Again, this is using no reach routing method at all. So let's take a look at our results at CP2. And as we expected, here's the calculated results with no routing. And then here is the observed results. This is flow rate. I'm going to use Muckingham routing. And what I'm going to do is set a certain value for K, X, and N. Let's go ahead and just use some arbitrary numbers first, look at the results, and then modify it. So I'm going to go to reach. Muckingham is the method. I'm going to say K is 1 hour, X is 0, and subreaches is 1. Okay, click apply. Okay, and then let's compute that and see what we get. Right click and check out the plot. Okay, definitely closer than it was before. We still have more lag and attenuation we need to introduce. So I'm going to take a quick look at the data, and this is where the calibration takes on a little bit more difficulty. You kind of have to observe the two different data sets and then make some educated predictions as to what to change before testing it again. For instance, in the calculated peak, it looks like that occurs at 930 CFS at 445. But then in the actual observed peak flow data, that is at 6:15, so an hour and a half later. Right now, my K is 1, but let's add 1.5 hours to make it 2.5 and then see what happens. So reaches, there we go. It is currently 1. I'm going to add 2.5. Now I'm probably going to have to also change the x value, but let's go ahead and just see what this does to matching up those peaks and valleys in the two different flow observed and computed through CP2. Okay, so compute, close. I'm going to go right click, plot. Okay, so yeah, a little bit different. This is calculated in green. This is observed in red. And I'm pretty sure we need to modify that x value. 0 means max attenuation and 0.5 is no attenuation. So let's go ahead and change that, and then we might have to tweak the K or the number of subreaches. So let's click on reaches once again. I'm going to change this to, how about 0.25, which is sort of a mix between no attenuation and zero and max attenuation. So click apply. Okay. And then let's compute once again. Okay, that's done. Right click and plot. All right, we're getting a little bit closer. You can see that our green line, the calculated flow through CP2, is getting much closer to our observed data in CP2. Next step, I would probably modify the X value again and leave the number of subreaches at 1. And as you can see, once we get closer and closer, then our model more accurately represents what was observed. And I'm going to stop right there for the sake of keeping this video fairly short, but you get the idea of how reach routing can be an important factor when creating your ResSim model. And a few different methods and strategies about how to do that by setting up an alternative, picking your routing method, as well as calibrating the parameter values.